Right now, inside a dark concrete silo at the port of Amsterdam, the biggest cocoa gateway on Earth, 60,000 tons of chocolate are trying to catch fire on their own. No sparks, no outside flames, and no visible warning. It is a silent physical process in which cocoa's natural oil reacts to the pressure of towering masses of beans, creating heat that feeds itself. If the ventilation system fails for just a few minutes, what you know as a multi-billion-dollar industry turns into an uncontrollable furnace worth tens of millions of dollars. What you see on the shelf, wrapped in colorful foil, is the survivor of a full-scale logistical war. Behind every luxury chocolate bar, there is an invisible structure of giant vacuums, robots with scent sensors, and ships that reroute around conflict zones at a cost of $300,000 per voyage. Welcome to Invisible Structures. Today, we are going deep into the guts of the biggest food machine on Earth to understand how extreme engineering keeps the global supply from literally vanishing before it ever reaches your table. And this story hides one detail that shatters every expectation. Cocoa, in the exact state it comes off the tree, tastes absolutely nothing like the chocolate you know. None of that familiar sweetness, and none of that inviting aroma. The flavor you love only begins to exist after an extremely controlled sequence of steps that determines whether that batch becomes luxury chocolate or gets thrown away as a multi-million-dollar loss. One small temperature mistake anywhere in this global chain can ruin entire tons of production. So before we go on, subscribe to Invisible Structures, because what happens behind the technological curtain, where nobody looks, is fascinating. Have you ever stopped to think about how many different countries the chocolate you eat actually comes from? The answer is far from obvious. Before crossing oceans and entering automated factories, cocoa must undergo an invisible transformation. It stops being a simple farm product and becomes a standardized global commodity. The exact moment it leaves the farmer's hands, it enters a much larger machine, a silent network linking remote regions to the most advanced industrial hubs on Earth. It all begins with the strict organization of the harvest. After drying, where the beans must reach exactly 7.5% moisture, they are packed into large sacks. These locations act as the first nodes in this invisible network. Here, cocoa is weighed and graded by intelligent systems. That detail changes everything, because from this point on, cocoa becomes a tradable unit in the global market. Try to picture the massive scale. Thousands of small farmers feeding centers that consolidate tons of cargo every single day. What truly sustains this system is not just volume, but precision. Each batch must meet extremely strict quality criteria measured by digital probes. If anything is even slightly outside the industry standard, the entire batch instantly loses financial value. In other words, before it even leaves its country of origin, cocoa is already part of a system ruled by rigid industrial standards. And then, the physical movement begins. Trucks take over, hauling these batches across roads that often span entire regions until they reach commercial ports. And here, a massive shift happens in the economy. Cocoa officially enters the world of heavy infrastructure. We are talking about colossal port warehouses, concrete storage silos rising 10 meters high, and industrial ventilation systems working to ensure the cargo does not spoil. Unlike many other products, cocoa is extremely sensitive to heat. Now imagine the engineering challenge of keeping tons of beans stable in scorching tropical environments, under constant time pressure. When cocoa finally reaches the port, it enters a system operating on a planetary scale. Massive cargo ships and extremely strict schedules now determine the final destination of that valuable load. We are talking about giants like the Rubina, a ship that alone carries around $175 million worth of cocoa in a single intercontinental voyage. To give you a sense of scale, there are even bigger leviathans, like the MSC Turkey, a true floating steel city nearly 400 meters long. It stretches farther than 4 football fields lined up end to end. These giants cross the oceans carrying thousands of containers, facing an invisible challenge: keeping cocoa quality intact through weeks at sea. Throughout the journey, there is a danger sailors know well called internal rain. When a ship leaves warm tropical waters and reaches the icy waters of Europe, moisture inside the steel hold condenses and literally begins to rain onto the cargo. If the ship's ventilation system fails for just a few hours, this internal rain can destroy nearly half the product with mold. And the complexity deepens when we look at the world map. International tensions and blockades along key routes are forcing these floating cities into a massive detour around the southern tip of Africa. Instead of entering the Red Sea and passing through the vital Suez Canal, ships now travel down the entire African coast and round the Cape of Good Hope in South Africa. This route change adds 15 full days to the journey, and the financial impact is brutal. Each ship making this detour burns an extra $300,000 in fuel per trip. $300,000 vanishing inside these giants' engines just to ensure the cargo arrives safely. But this precision comes with an invisible cost: time. In high-performance logistics, we work with what is known as the critical path. When global demand rises, the system's margin disappears. If a ship like the Rubina is delayed by just 2 days at port, the impact is felt in factories thousands of kilometers away. It is a system that allows no errors, where the delay of a single link can halt production across an entire continent, turning planning into a multi-million-dollar loss in a matter of hours. While the ship physically crosses the ocean, billions of dollars are moving digitally in parallel. A delay of a single vessel at a European port can affect entire factories on the other side of the world, proving that we are all connected by this invisible structures of global transport. When these steel giants finally dock at major ports, one of the most impressive operations in modern engineering begins. How do you remove tens of thousands of tons of a fragile grain from a hold as deep as a building? The solution is not manual, but a massive automated choreography. Vacuum systems take the stage, functioning like the largest vacuum cleaners ever built. These industrial towers generate overwhelming suction power, capable of pulling in 1,500 tons of cocoa per hour. The vacuum power is so precisely calibrated that cocoa beans literally float and surf through air currents inside massive metal tubes, preventing the seeds from breaking on impact. But the technology goes beyond suction. Inside the dark warehouses where cocoa is stored, high-precision robots operate, known as spider claws. These machines have mechanical arms that spin in every direction in fractions of a second. Equipped with delicate sensors, they dive into containers and handle 100-kilogram sacks with eerie ease, as if they weighed nothing. All this mechanical force is coordinated by a control center that monitors every movement in real time. This is not just brute strength, but synchronization. Position and load sensors ensure the claw operates at maximum speed without ever compromising the integrity of the beans. It is a centralized monitoring system that protects the inventory and ensures port operations never stop, even when external conditions change. Without this constant automated oversight, processing the volume required to supply the global market would be impossible. While the robots work, the environment is watched by an artificial sense of smell. Spread throughout the silos are devices known as electronic noses. These intelligent sensors constantly smell the air to detect early signs that the cocoa is beginning to spoil. These digital noses can sense a problem days before any human could notice something is wrong. If these sensors detect even the slightest change in air chemistry, the system triggers an alert and activates massive fans to cool the cargo and prevent the ghost fire we discussed at the beginning of the video. We know how important knowledge is, and we want you to learn something new with every video. Did you learn anything new today? To keep following this route where the real world happens, your subscription to Invisible Structures is what keeps our compass pointed toward the next hidden secret. And keep exploring the structures that sustain the world. After passing through this maze of vacuum systems and robots, the cocoa finally reaches the factories. Here, the goal is to transform a constantly changing raw material into a standardized, flawless product. Engineers at major facilities now use the concept of a digital twin, a complete virtual model of the entire production line inside a computer. This allows them to simulate how the chocolate will behave before the real machines are even turned on. Inside the factory, cocoa undergoes an intense physical transformation. The beans are roasted in massive industrial drums where heat control is handled with extreme precision. A difference of just 2 degrees can turn delicious chocolate into something burnt. After roasting, the cocoa is ground until it becomes liquor and cocoa butter. The most mysterious stage of the entire process is refining the mass. Colossal machines work this mixture for hours or even days, making the texture so fine that the human tongue can no longer detect any grain. This is what creates that sensation of chocolate melting in your mouth. But the true engineering mastery lies in the final temperature control. The liquid chocolate must go through an extremely precise cooling and heating cycle to control how the fats crystallize. If this process fails, the chocolate turns dull, pale, and loses that signature snap when you break a piece. All the beauty and shine you see in the final chocolate are direct results of a system that monitors it at a level beyond what our eyes can see. It is science applied to the pleasure of eating. And while all this happens, sensors track every detail in real time, ensuring the flavor is always the same. After crossing remote plantations, modern ports, dangerous oceans, and highly automated factories, chocolate finally reaches its final stage. But even finished and packaged, the work of the invisible system is not over. Massive warehouses organize thousands of units in real time, using predictive calculations to ensure markets never run empty during peak demand. A single computer error in these calculations can mean millions of dollars in losses or empty shelves across entire cities. Up to the very last second before it reaches your hands, heat and humidity are still controlled inside specialized trucks crossing the country. You walk into a store, see a neatly stocked shelf, and pick your favorite chocolate. It feels simple, but now you know that behind that moment is a global network operating with surgical precision. We have seen giant ships rerouting around wars, monumental vacuums pulling tons of beans, robots handling heavy loads, and electronic noses guarding against invisible fires. Chocolate is not just food, it is physical proof that our modern world only works because of these structures you cannot see, yet must perform flawlessly every day. The more efficient and sophisticated a system becomes, the more invisible it is to those on the outside. Today, we have witnessed the absolute dominance of engineering over the challenges of nature and time. Now, I want to leave you with one final thought. After seeing all this monumental technology, what unsettles you more? The complexity of a cocoa silo monitored by robots and vacuum systems, or the realization that, right now, almost everything sustaining your life depends on systems you did not even know existed? We live surrounded by silent mechanisms that keep the world running, and our mission is to reveal them. Leave your answer in the comments and tell me, which great invisible structure of our planet have you always been curious to understand from the inside? Your idea could become the subject of our next major investigation here on the channel. Do not forget to subscribe to Invisible Structures and turn on notifications so you do not miss our next deep dive into the depths of human technology. Why not check out our playlist, How Invisible Structures Sustain the Modern World? That way, you can explore everything we have here. Thank you for watching, and see you at the next encounter with the invisible.